Alright guys, today we're doing 3.5 rational functions, so it'll probably be a 2-video lesson, but basically the idea here is recognizing what a rational function is and what we need to do to graph one or sketch one. So just as kind of a side note, I'm going to abbreviate rational as RATL, and I'm going to abbreviate functions as FNCS. So don't let that throw you off. Alright, we're going to start with a definition of what a rational function is. A rational function is a function that can be written in the form f of x equals p of x divided by q of x, where p of x and q of x are polynomials. Now, that's the definition. Recognize as a special note here, the domain of f of x must exclude any values that cause q of x to equal 0, right? Because q of x is our denominator in this situation, so the domain of f of x has to exclude any values that make q of x equal 0. So let me give you an example of that. So f of x equals 3x to the 4th plus 5x squared plus 7x minus 1, all divided by x squared plus 2x minus 15. So f of x, the domain of f of x, we have to look at what the bottom, what sets the bottom equal to 0. So you can factor that real quick and see that you get x plus 5, x minus 3. So this domain of f of x must exclude -5 and +3. Okay. What's interesting and what we're dealing with here in rational functions is what happens at these points. What happens when x does equal -5, and what happens when x does equal 3, or what happens when we get really, really close to those points. What you're going to find is the graph does some really strange things when we get really close to these points that cause it to be 0. Something else I want to go ahead and note here, we're going to give the definition of vertical asymptotes here in a minute. You find your vertical asymptotes by finding what makes the denominator 0. So for this f of x, we know there would be 2 vertical asymptotes on that graph at these x values. But we'll get more into that later. But some strange things begin happening in the graph of f of x at those points. Alright, so let's get some notation out of the way. We say x approaches a from the right with this notation. X approaches a from the right. If I write it this way, we're saying the same thing, except that x approaches a from the left. F of x approaches infinity. Writing it this way is just another way of saying f of x increases without bound. And then writing it this way, f of x approaches negative infinity. Sometimes you'll see it behind it, sometimes you'll see it in front of it. It doesn't really matter. It says the same thing. It says f of x decreases without bound. Okay, so just a real quick example of that. If I said f of x equals 1 over x, the graph of that is going to look something like this. This is just a rough sketch, right? But here this is increasing, decreasing, etc., etc., etc. All right, so that lays down some notation that we need for rational functions. So now let's start setting up some other definitions of horizontal asymptotes, vertical asymptotes, and start graphing these things. All right, so let me give you a definition of a vertical asymptote. The vertical line, x equals a, is a vertical asymptote for the graph of f if, f of x approaches positive or negative infinity as x approaches a. Okay? So the line at x equals a is a vertical asymptote if the function approaches positive or negative infinity as x approaches a. So in this situation we have one vertical asymptote, right? And it is the y-axis. Well, why is it the y-axis? Well, because as x approaches 0, this function on this side approaches negative infinity, and on this side it approaches positive infinity. So in this situation, our vertical asymptote is just the y-axis. Okay? So let me give you a definition of a horizontal asymptote. The horizontal line at y equals c is a horizontal asymptote if f of x approaches c as x approaches positive or negative infinity. Okay, and I'll give you an example of that here in just a second. So when you're putting the graph of rational functions, when you're sketching it out, you're going to have vertical asymptotes, you're going to have horizontal asymptotes. You're also going to have possibility of oblique asymptotes, but we'll get to those probably in the second video. All right, let's look at an example of sketching one of these things. Let's say we want to sketch f of x equals 1 divided by x minus 2. Well, let's just deal with the vertical asymptotes and the horizontal asymptotes. All right, so look, in general, we'll just make a chart. X values and then the function. Well, we know that if we put 2 in here, we get 0 in the denominator, right? So we know something funny is going to happen there. So let's see what happens when we get really, really close to the value 2. So let's say we put the value 2.1 in for x. Well, our result there would be 10. What if we got even closer and said 2.01? The value would be 100. And you can go on and on down this line, 001. We'll give you 1,000, and then 2.0001 is going to give you 10,000, and you get the picture. So as we approach x, or 2 in this situation, from the right, and we get closer and closer to 2, this value gets larger and larger and larger. Right? So here's our conclusion. Thus, f of x approaches positive infinity as x approaches 2 from the right. Now what if we did it the opposite way? What if we approach 2 from the left? So what if we said, instead of here we said x equals 1.9, 1.99, and so on, and get closer and closer and closer to 2, coming from the left. Well, you would get negative values here. These numbers wouldn't change, they would go to negative values. And our conclusion there would be f of x approaches negative infinity as x approaches 2 from the left. What that tells us is 2 is a vertical asymptote. Going back to our definition, f of x approaches positive or negative infinity as x approaches a. Well, x in this situation, or a in this situation, is 2. And as we approach it, we see we bend to positive and negative infinity. All right. Well, what about in another situation? What if we said let's let x get really large? So let's make another chart. We're going to do the same thing. What if I said let x equal 100? Well, your value in that situation would be 0.01. Equal 1,000 would be 0.001, and so on and so forth. You'll see the picture that we're trying to portray here. 100,000 equal 0.00001. Okay? So what does this tell us? Well, this tells us about the horizontal line, the horizontal asymptote. So f of x approaches 0 as x approaches positive infinity. So as x gets larger and larger and larger, the function value is getting smaller and smaller and smaller. So f of x is getting closer to 0 as x gets larger. And then if we plugged in the opposite side of that spectrum, we would see that f of x approaches 0 as x approaches negative infinity also. What that tells us is we have a horizontal asymptote at the value 0. Okay? Alright, I'm going to cut that video off right here. We'll pick it up with part 2. And I'll give you some rules and guidelines to follow on finding horizontal asymptotes and actually sketching these graphs.